Oops. Hi everyone, I'm Ming. I'm from Ireland University of Amsterdam. I'm going to present our paper about masks and swept sequence modeling for next novel basket recommendation in grocery shopping. This is a joint work with Mosde, Andrew Yes, and Martin Drake. So first, let's quickly recap what is next basket recommendation. So first of all, you go to the supermarket, will purchase a set of items instead of a single item. And for the user sequence, it is a sequence of baskets. And next basket recommendation is based on the user's historical interactions and predict the next basket, next set of items that user may have interest in. Oh, we have done previous research about the repetition exploration in the next basket recommendation, where we, instead of assessing the overall performance as a whole basket, we look into a fine grain level and separate items into repeat items and explore items. Where repeat item refers to the items that user have previously interacted with, and explore items refers to the items are new to the user. And in this research, we found quite a lot of interesting findings. One of them is that this one. So basically, the blue bar refers to the contribution of repeat items to the accuracy, and the orange bar refers to the contribution of exploration items to the accuracy. So which means that the performance of the correctly predicted items are mainly repeat items, and yes. And we also found a huge imbalance between repetition task and exploration task, where repetition task is much more easier than the exploration task. And so the improved performance is mainly from being biased towards the repetition task given the limited resource. And after this work, some NBR studies have focused on the pure repetition setting, where they aim to recommend a basket which only contains the repeat items of the user. And also, you can see some real-world applications have designed by the gain service to isolate repetition recommendation from their recognition, mainstream recommendation. However, one main goal of recommender system is connecting items and users. So the exploration task is also very important. And we can imagine that users might get tired of seeing the same item again and again. And in some platforms, you may have seen try something new function, which is actually a pure exploration setting. So in this paper, we formulated a recommendation task which only focuses on the exploration setting, which is called next novel basket recommendation. So given historical interactions of baskets, and we are going to recommend a basket which only contains the new items and explore items. So after defining this problem, and we are interested in how existing NBR method performed on this novel basket recommendation task, of course, we can think about two ways of training existing NBR methods. First thing is that we can use all items in the last basket as the training labels, so that the models are trained for basket recommendation, so it should have the ability of finding explore items for the user. And the second is that we can actually modify it for the pure exploration setting, which is that we can removing the repeat items and only using the explore items in the last basket as the training labels, so that the model is trained specifically for the exploration task. And we found that removing repeat samples lead to improvements in many cases, in many baselines, but not always. Which means that when you use the existing NBR methods at baseline of services, you cannot just remove the repeat items and directly. You should try both ways. After we define this model and understanding the existing baselines, the question is to how to model and train for the next normal basket recommendation task. So the first thing is that how to model for the exploration. So we can first think about the differences between repetition and exploration. So for the repetition task, the candidate items are only dozens. The users have previous interaction with the candidate items, and the model can only need to predict whether a candidate repeat item will appear or not in the next step. But for the exploration, you usually have the thousands of millions of items from the whole catalog, and we have no previous interaction with the explore items. And in that sense, we need to infer the explore items based on their interactions with existing items that user has interacted with. So in that sense, the item-to-item correlations is very important in this thing, such setting. So we only need to predict. We only need to propose a model which is based on transformer, where we can only use the position embedding to represent the items in the same basket. It is very simple. And this simple model actually allows us to learn item-to-item interaction directly within the basket and across basket. And after defining this simple model, and the question becomes to the how to train this simple model for the exploration task. As we can see that in the basket recommendation setting, we have a definition of basket. We can actually think about two levels of training. The first one is item level masking, which is actually a cross-tag widely applied in some other recommendation scenarios, where we mask an item and try to predict the masked item based on its surrounding items. And an advantage of using this is that it allows us to generate a lot of flexible training signals, but actually it is not for the basket recommendation task, and it does not strictly follow the temporal orders in the basket sequence. And the second way of masking is basket level masking, where we can mask the last basket of the basket sequence. And so this model is actually trained specifically for the basket recommendation task. Note that we are training this model for the exploration. We are in a scenario that both repetition and exploration behavior coexist. And these repetition signals might serve as shortcut or noise for the exploration task. So first thing is, let's look at the cross task item level masking. The conventional way of a very simple way of random masking, item level masking, is that we can randomly mask the items in the sequence, and we are going to predict the masked items. However, when we train using this way for the exploration task, it had an issue. It is that, for example, in this sequence, we masked item 1, but the model, the item 1 also appears in some other locations of this basket sequence. The model might only rely on its occurrences in some other locations of this basket sequence and fail to learn the item-to-item correlations between or within different items. And we propose a second novel masking method that is specifically for the exploration task, which is that we first select the items we want to mask, and then we mask all of the items occurrences in the basket sequence. So that in this way, we are going to force the model to infer the new items based on the item-to-item correlations within different items. And similarly, we can also think about using this way for the basket level masking, where we can actually mask all the items in the last basket, and we can also remove the repeat items in the last basket and only mask the explorer items in the last basket of sequence. And here is a summary of different types of masking strategies. We actually consider the repetition and correlation, and we also consider the different levels of masking. So item level masking actually do not have strict temporal orders, but it actually allows us to generate a lot of flexible training signals. But basket level masking, it actually strictly follows the temporal orders of the basket sequence, but the training signals is not very much. Yes, so here is some results. I can summarize the results. So first thing is that the very simple transformer-based basket recommendation model outperforms many baselines. And second is that the item selective masking always outperforms item random masking strategy for the exploration task. And the third is that on 2 data sets, we found that item level masking outperforms basket level masking, but on another data set, at basket level masking outperforms item level masking, which means that the temporal orders might be very strict on some data sets. It actually, the performance actually depends on the scenarios or data sets you use for the task. And of course, we can also consider a joint masking strategy, which is that we can first use item level masking and to allow us to generate a lot of training signals and learn item-to-item correlations. And then we fine-tune it by using the basket level masking for the basket recommendation task. And we found that this joint masking strategy is very robust. It can achieve best performance on across all the data sets. And beyond that, we also consider the flexible orders during the sequence modeling, because in the grocery shopping scenario, it does not actually matter whether you bought an apple today or tomorrow. So we can actually swap the items between baskets to generate more training signals. And we use swap hope to control the swapping distance and swap ratio to control the number of swapping items. And we found that the flexible orders can further help further help for the model to solve the exploration task in the grocery shopping scenario. So that's it. I'm happy to take any questions.
Thank you. Do we have any questions in the audience?
Okay, thank you for an interesting talk. So your model is somewhat similar to a regular transformer encoder model, transformer encoder, but the biggest difference which I see is that you share positional embedding for the baskets. So did you try to just use normal positional embedding without sharing them, just sequentially use kind of one after another, and like how much difference does it have with sharing positional embeddings?
Do you mean how to consider the classical sequential models one after another?
Yes.
So for the one interesting about the basket recommendation scenario is that the items within a basket do not have sequential, do not have orders. So we cannot do that. because because we only have sequential orders between baskets.
Okay.
Yeah, I think, but it was a try, I think, because.
I mean, like, if there is no order in theory, you can reinvent, like, just introduce this order randomly, for example. Okay, but fine,
Yeah.
thank you.
Thank you.
So I have a question. We're in the application session. We've heard about news. We've heard about matching. We heard about a food data set. What would be the application of this? Where would you apply this?
So we are going to apply this in a scenario which specifically we are talking about the grocery shopping scenario, but I think it is interesting to extend this method to any scenario that has both repetition and exploration behaviors. So, for example, for the music recommendation, they may also have re-listening behavior. So this paper is not only about actually it is not only about the grocery or basket recommendation scenario. It actually mainly tells us how to train the model, how to define a model in a scenario with both repetition and exploration behaviors. So, yeah.
Okay, thank you. Do we have any more questions from the audience? Okay, so thank you. This was the application session. Please, all authors and everyone who attended, go to Slido. There's a few questions that popped up after the presentation, so if you have the time, please answer them. Let's give the speakers another round of applause. And now we have a coffee break. After the coffee, there's a session on sequential recommenders here, I think. Yes, sequential recommenders here and graphs in the other auditorium.